Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky, talking about the week of April 28th this time around. So let's look at the planets in the evening sky. Jupiter, well, let's start there. We started with Mars on the board. Let's start with Jupiter. Jupiter is up about 3 hours after sunset right now. So still well out of the glow of sunset, but getting closer all the time. We want to be paying attention to that. It starts the week about 3.5 degrees away from the supernova remnant, the Crab Nebula, M1, and it ends the week about 2.5 degrees away from the Crab. Now, the Crab's hard enough to see. It's not the best object in the world to track this motion next to, but very near the Crab is third magnitude Zeta Tauri, and it's only about a degree southeast of the Crab. Is this third magnitude star. So that's the star you're looking for. And it's a star that, if we think about the Hyades star cluster that forms the face of Taurus the Bull, we extend these out, often pictured as the horn. You have El Nath at the top, nice bright star, and we have Zeta out here at the bottom. And M1 sits just above Zeta. So if you got your telescope and you want to go look for this, you got a good low moon to start the week for sure. You want to go look for the Crab Nebula. The best way to do it is to extend the V out on the bottom, the horns of the bull, out to Zeta, and then just scan up about a degree. Take your telescope and move up to the north, and maybe to the west just a little bit, and see if you can find the Crab Nebula right there. But finding Zeta, you're going to be able to track Jupiter's motion towards Zeta, and notice that it is moving quickly enough to actually see that separation from the star get cut by a factor of a third or something like that, a quarter. This week. Zeta Tauri is an interesting enough star for us to talk about. Zeta Tauri is what's known as a BE star. B stars, very hot, high mass stars. There are O stars or hotter and higher mass stars, but there aren't many O stars out there. So B stars, of the stars that you actually can see and find really well, B stars are there. But it's a BE star, meaning its spectrum, when you take the light and you break it into the component colors, its spectrum has emission lines. This is rare for a star. Most stars have absorption line and not emission lines. And this emission lines of these stars. Absorption is dark lines on a bright background, and they come from electrons making transitions upward in atoms. So you think about it this way. You got the light being emitted from the surface of the star, whatever the surface of the star is, the photosphere of the star, where we see this light being emitted. It passes through material, and as it passes through that material, it kicks electrons from lower levels up into higher levels. And that causes light to be absorbed or scattered out in other directions. And you see a dark line up here. But in these, you see emission lines, and that's from excited electrons dropping back down into lower levels. And so you see the emission lines right here. All of this is due to a disk of material around the star. These BE stars are very rapid rotators. So the rotation period is about a day for Zeta Tauri that we're talking about right here. And by comparison, the sun's rotation period is 27 days. It's a differential rotator, so it has a different rotational period at the equator than it does at the poles. But the sun has, let's say 27 days is its rotation period. So this is spinning about 27 times faster. So it's spinning pretty well out there. Now that causes the star, apparently, we don't have these things modeled all that well, but it causes the star to throw off material, and you get a disk of material. So the star itself is about 5 to 6 times the size, the radius of the sun, the diameter of the sun. And the disk has a diameter that's maybe 60 to 70 times the diameter of the sun. The radius is 60 to 70 times the radius. So you've got this big disk of material that's presumably been thrown off from the star because it's spinning so rapidly. And you see infrared emission from this disk, and it's got variable. It's not constant. It's brighter at times and dimmer at times that you see here. So these BE stars are, we think, just leaving the main sequence. Remember, we've talked about main sequence stars before. Most of the stars that are out there are quietly fusing hydrogen, the lightest chemical element, into helium, the second lightest chemical element, deep down into the cores right here. When that's exhausted, when all of that core right there becomes helium, then something else has to happen. And that something else that happens is you transition from being what's called a main sequence star, where that's happening, to being a giant star on the red giant branch, where you're starting that fusion in a shell around that inert helium core. So hydrogen is being converted into helium around that shell. We think that these BE stars are just right at the beginning of that transition to becoming giant stars. So we often classify them as subgiant stars. So they're not quite red giant stars yet. They're on their way up to be red giants. So this is what's going on. Very interesting star. So track Jupiter, moving toward the Crab Nebula. If you've got a telescope, use Zeta to find the Crab Nebula if you can, because it's just a degree away there. But then also take time to appreciate Zeta for what it is, this interesting BE star, a class of stars, a high mass, hot star that's just leaving the main sequence. Mars, meanwhile, in the evening sky, is in Cancer, and last 2 weeks we've been talking about it approaching the Beehive Cluster M44, and this week it really closes on the Beehive Cluster. But the beginning of the week, on the 28th, you've got about 3 degrees away. The Beehive Cluster is a naked eye object, so if you've got dark skies, you don't need binoculars or anything. By the end of the week, the moon will be about half full and in the region washing it out, so you'll need binoculars to see the beehive there. The moon's not going to be our friend, even though it's not super full at that point. But by the end of the week, by the 4th of May, that evening, then it's going to be 2/3 of a degree from M44. So Mars is really closing on the Beehive Cluster. And on the evening of the 3rd into the morning of the 4th, so really this is best done just after dark, probably on the evening of the 3rd, you've got the moon sitting just above Mars, only about 1.5 degrees. Remember, your finger at arm's length is a degree. So only about 1.5 degrees separate the moon and Mars is only about 1 degree above, 1 degree to the northwest of the Beehive Cluster on that night. So if you got binoculars, again, the moon will be washing out the Beehive Cluster at that time, but those are big, bright stars. And so I'm guessing binoculars will still pull that out for you. So you'll see the moon and Mars and the Beehive all there together in your binoculars. Should be a great night to go out and check that out. So that's my recommendation for the week. I recommend paying attention to Zeta Tauri too. These are really good things. Now, first half of the week in particular, the moon is much less. By the end of the week, it's only filled out to about half full. And so the first half of the week, you've got a waxing crescent moon, and that waxing crescent moon isn't all that bright and sets relatively early, so it's still a good time. Leo, we talked about Leo last week in the galaxies in Leo, another good week to do that. Leo has this triangle tail and the backward question mark head, Regulus, that bright star right there. And the Chertan we used last week is this star. I seem to be not writing the last letters of the names on the board here. Chertan looks more like that to me, a little bit more elongated. But Chertan is, it's too much now, but whatever. Chertan is this star we dropped straight down from Chertan last week to see M65 and M66, 2 beautiful spiral galaxies that you can see in binoculars. We got 3 bright galaxies over here, 2 spirals and an elliptical. So if we go this direction, we come to Rho Leonis, and Rho Leonis is a 3rd plus magnitude star out here. It's not as bright as Zeta, I don't think. So we're talking about something closer to 4th magnitude for Rho Leonis out here. So you go about 12 degrees, and it's the brightest star you come to angled off that direction. Go about 2/3 of the way down toward Rho Leonis from Chertan, and you've got a nice tight group of galaxies, M95, M96, and M105 right across there. M105 is an elliptical galaxy. M95 and M96 are the spiral galaxies. Elliptical galaxies are often bigger and brighter, the giant elliptical galaxies that we see here, but they don't have any dust and gas. The spiral galaxies have these flattened disks with dust and gas where new stars are being formed, and you got all this stuff, like they're becoming BE stars and all this stellar evolution stuff going on. Less of that going on in ellipticals because there's just not material there to make new stars to cause this see this whole cycle of evolution. These 3 galaxies, I've expanded them out a little bit. They're actually much tighter than that. I just wanted to draw the picture like that. There's about 1 degree and 1 degree and 1 degree. So if you got a nice telescope, you can probably, it probably doesn't take a real big telescope. You might be able to see these with binoculars too, even like we talked about with 65 and 66 last week. But you've got a 4-inch telescope or a 6-inch telescope and a nice open wide eyepiece. You should have no trouble finding all 3 of these and getting at least 2 of them in your eyepiece field of view at one time. You might have to scan around to get the 3rd one in there, but you can see these 3 objects. Now, M105, the elliptical galaxy in this group, is a part of a tighter group itself with NGC 3384 and NGC 3389. These are both spiral galaxies, and they're fainter than, one of them is pretty big, but they're both fainter than M105 and harder to see. And I'm going to recommend more of a 10 or 12 inch class telescope to be able to see those. But they're close enough together that you use a nice low power eyepiece in your 10 or 12 inch telescope and you should be able to see all three of M105 and NGC 3389, NGC 3384. So that's what we got. We got the moon starting very close to new, just past new, and filling out to be about half full by the end of the week. We've got Mars closing on the Beehive Cluster. We've got Jupiter closing on Zeta Tauri with the Crab Nebula and supernova remnant from the year 1054. Beautiful nearby there. Zeta Tauri is a great example of a BE star, so it's worth observing that, just thinking about what's going on with that star. And then we got a few more really good galaxies in Leo for us to look at. We'll take a couple weeks of a break from looking at these galaxies in Leo and Virgo, at least a couple weeks of break because we got the moon. Will be impinging on our viewing the next couple of weeks, but then we might cycle back and find some galaxies moreover in the Virgo direction in a few weeks. So that's it. Have a great week, everyone, and as always, thanks for watching.